Number 1 tells us that an artist is selling children's crafts. Necklaces cost $2.25 each, and bracelets cost $1.50 each. Select all combinations of necklaces that the artist could sell for exactly $12. So A says 5 necklaces and 1 bracelet. So then we're going to take 5 times the $2.25, since each bracelet costs $2.25. And then we're also going to add 1 bracelet at $1.50. So then you can just calculate this, and 5 times $2.25 is $11.25. And then plus the $1.50, and that's going to be more than $12. And we need it to be exactly $12. For part B, and so we're going to continue that on. We're going to take the number of necklaces always times the $2.25, and then the bracelets times the $1.50. So 2 times $2.25 plus 5 times $1.50. And 2 times $2.25 is $4.50. So we're spending $4.50 on we're making $4.50 on the necklaces. And then 5 times $1.50 is $7.50. And this equals exactly $12. So part B would be good. C, we're going to do 3 times the $2.25, which is going to be $6.75. 3 times $1.50 would be $4.50. I can tell immediately this one is wrong because 75 cents and 50 cents does not equal an even dollar. So we're not going to get to exactly 12 on that one. Part D, 4 times $2.25 is $9. 2 times $1.50 is $3. 9 plus 3 is exactly 12. E, 3 times $2.25 is $6.75. And then 5 times $1.50 is $7.50. And again, 75 cents and 50 cents doesn't equal an even dollar. So that's definitely not going to be exactly 12. 6 times $2.25 is going to be $13.50. And then that's already over the 12. So for sure that's not going to work. And it was 0 bracelets. So another $0. Then this one is no necklaces. So 0. And then 8 times $1.50 is 12. So that does give us exactly $12. Number 2, Diego is collecting dimes and nickels in a jar. He has collected $22.25 so far. The relationship between the numbers of dimes and nickels and the amount of money in dollars is represented by this equation. So 10 cents per dime plus 5 cents per nickel totals $22.25. So select all values of dimes and nickels that could be solutions to this equation. So in this one, we're taking the first number is our dimes, our number of dimes, and our second one is our number of nickels. And actually then when I'm looking at this, I would cross off B right away because we can't have half of a dime. So those numbers need to be whole numbers because we can only have whole values of dimes and nickels. So B would be out right away. Then in A, so we're going to have 0.10 or 0.1 is fine times 0 dimes, okay, plus 5 cents or 0.05 times 4.45. And so if we calculate that out, 0.1 times 0 is just 0. And then 0.05 times 4.45 is going to be 22.25. So this one does give us $22.25 if Diego had all nickels. So this would be all nickels. Part C, we're going to do 0.1 times 233. So 10 cents. He's got 233 dimes. And then 21 nickels. Whoops, 0.05, not 0.5. So 5 cents per nickel, and he's got 21 of those. So 0.1 times 233 is 23.3. And then 0.05 times 21 gives us 1.05. Although that's already over. You could see right here it was already over his total, so that's not going to be a solution. D is 0.1 times 118 and 0.05 times 209 for the number of nickels. So he's got $11.80 in dimes, plus he has $10.45 in nickels, and this totals $22.25, which then means it is a solution to this equation. Part E, he's got 172 dimes, and he's got 101 nickels. So 10 cents times the dimes gives us $17.20 in dimes. And 5 cents times 101 nickels gives us $5.05 in nickels for a total of $22.25. So that one is a solution as well. Number 3, volunteer drivers are needed to bring 80 students to the championship baseball game. Drivers either have cars, which can seat 4 students, or vans, which can seat 6. The equation 4 times the number of cars plus 6 times the number of vans equals 80 describes the relationship between the number of cars and the number of vans that can transport exactly 80 students. Select all statements that are true about the situation. So if 12 cars go, then 2 vans are needed. So 12 cars would give us 4 students each. So 12 times 4 means that 48 students can be transported by those cars. So then 2 vans would mean 2 times 6 would be 12. So if we had 48 in the cars and 12 in vans, that would be able to transport 60 students, not 80. So this is false. We would need more vans than 2. Part B, if the cars equal 14 and the vans equal 4, that's a pair of solutions. So let's look at 14 cars transport 4 people each, which would give us 56 people. And then 4 vans transport 6 people each. So 4 times 6, 24 people could ride in the van. And 56 plus 24 gives us 80. So that is a solution. C, if 6 cars go and 11 cars go, there'll be extra space. So 6 times 4 means 24 people can ride in the cars. 11 times 6, so 11 vans at 6 people each would be 66 people can go in the vans. So this means we have space for 24 people in cars, 66 people in vans, which is 90 people, which is greater than the space that we need of 80. So this is true. We would have extra space. D, 10 cars and 8 vans isn't enough to transport the students. So let's take a look. So 10 times the 4 spaces would give us 40 people to ride in the cars. 8 times 6 would give us 48 for the number of people in the vans. And 40 plus 48 gives us 88, which is more than the 80 people. So we have more than enough room. So that's definitely enough room. If 20 cars go, no vans are needed. So each car has 4 spaces. 20 times 4 fits all 80 students exactly. So that would be good. 8 vans and 8 cars are numbers that meet the constraints for the situation. So 8 times 6 gives us 48 because that's the van amount. And 8 times 4 is the cars. That gives us 32. 48 plus 32 equals the 80 that we need. So that is true. Number 4, the drama club is printing t-shirts for its members. The printing company charges a certain amount for each shirt plus a setup fee of $40. There are 21 students in the drama club. If there are 21 students in the club and the t-shirt order costs a total of $187, how much does each t-shirt cost? Show your reasoning. So you could tackle this problem a few different ways. I look at it as the total is $187. The setup fee is $40. This is a one-time fee. So if I subtract the $40 off of here, I would have $147 left for just the t-shirts. So this is just the t-shirts without the setup cost. And then the t-shirts, we had 21 of them. So then if I divide the t-shirt cost evenly, this would give me how much each t-shirt costs. And 147 divided by 21 is $7 per t-shirt. So that's how I look at it. You could also write out an equation for this. So you could say $40 plus the cost per 21 t-shirts, right? So you could put it like that. Or you could do it like this. Equals 187, and you could think of solving an equation. So then you could subtract 40 from both sides. So then you get 21c equals 147, and then you divide by 21. So then you get c equals 7 that way as well. So just kind of a different way to organize the ideas. Part B, if the equation 20150 equals F plus 650 times 21 represents the cost of printing the shirts at a second printing company, find the solution to the equation and state what it represents. So if we look at this, this is going to be the total, right? So this is our total cost. We know that this is the number of t-shirts because 21 people. So this is the number of t-shirts. So then this must be the cost per t-shirt. So this F, when we solve for it, is going to be the fee. So if we take and we just multiply out the 650 times 21, that gives us $136.50 for the actual cost of the shirts. Then we can just subtract that from our total. And we get $65 for the fee. And so that means that the setup fee is $65. So this one had a higher setup fee at $65, but a lower t-shirt cost at $650. Number 5, the box plot represents the distribution of the number of children in 30 different families. After further examination, the value of 12 is removed for having been recorded in error. The box plot represents the distribution of the same data set, but with the maximum of 12 removed. The median is 2 children for both plots. Explain why the median remains the same when the 12 was removed. So the let me get this set up here. So the median, the median isn't susceptible, I should say, isn't as, maybe we should say impacted, isn't as impacted by outliers as the mean. So it isn't changed very much by removing one data point. So in this case, there was likely a few or multiple families with 2 children. So if we think about, this represents 30 data points. So if we kind of think about a bunch of data points here and here, and then we had 12, and here in the middle, we had multiple 2s. So if originally, out of the 30 data sets, your median was here, because those would be your middle 2 numbers, your 15th and 16th data point, so that the middle was right here. Now, when you remove the 12, so when we get rid of this, now our middle just moves down to this value, just that value. So the median wasn't impacted when it just moves down 1 number if there was multiple there. Then for B, when 12 is removed from the data set, does the mean remain the same? Explain your reasoning. And so no, the mean would change because the total is lower now. So if we remove 12 from the data set, when we add all the numbers together, the total is going to be lower. So the mean would change because the total is lower now. So we would get a smaller mean. Number 6, the number of points Jada's basketball team scored in their games have a mean of about 44 and a standard deviation of 15.7. Interpret the mean and standard deviation in the context. So this data set means that the average Jada's team scores is 44, but with a standard deviation of 15.7, there is a lot of variability. That's a pretty big standard deviation. This could be because of some outlier games. Like maybe there was a big blowout, like they played a team that was a lot less skilled than they are and they beat them by a lot, and then maybe they also played some teams that were a lot better than them, so they had a really low scoring game. So this could be because of some outliers of the game, but if it isn't because of outliers, or even if it isn't because of outliers, then we would expect most of the scores to be within that 1 standard deviation. So if we took 44 minus 15.7, that would give us like 32 or 28 points. Okay, so we would expect most scores to be between 28.3 really, but I'm just going to round it to 28 since we can't score 0.3 points. So most scores to be between 28, and then if you do 44 plus 15.7, that would give you 59.7. So I'm just going to say 60. So most scores to be between 28 and 60 points. And again, the way I got these values right here, was to do 44 plus 15.7, so that 1 standard deviation, and 44 minus 15.7. So this gave me 59.7, so I rounded it up, and this gave me 28.3, so I just rounded it to 28. Number 7, Kieran's family is having people over to watch a football game. They plan to serve sparkling water and pretzels. They're preparing 12 ounces of sparkling water and 3 pretzels per person. Including Kieran's family, there are going to be 10 people at the gathering. A bottle of sparkling water contains 22 ounces and costs $1.50. A package of pretzels contains 16 ounces and costs $2.99. Let N represent the number of people watching the football game. S is the number of ounces of sparkling water. P is the ounces of pretzels, and B is the budget. which equation represents Kieran's budget? So we have a pretty specific amount here because we know that 10 people are coming. So for sparkling water, we know that we need 12 ounces times the 10 people. So we need 120 ounces of sparkling water. And we know that sparkling water has 22 ounces in each bottle at $1.50. So we need to make sure that we have enough for 122 ounces. So you could say one bottle is 22, a second bottle would give us 44, a third would give us 66, a fourth would give us 88. I'm just adding 22 each time. And then a fifth would give us 110. And then a sixth would give us 132. So we're going to need this much to cover that 120 ounces. So that's 6 bottles. So for the sparkling water, we need 6 bottles at $1.50 a piece. So here's our sparkling water portion. Then when we take a look at the pretzels, we are looking at 3 pretzels per person. So we're planning for 3 pretzels times 10 people. So we need 30 ounces of pretzels. We know that 16 ounces per package, that there's 16 ounces per package. So one package would get us 16. 2 packages would get us 32. That's more than the 30 we need. So we need 2 packages. So the cost of that would be 2 packages times $2.99 per package. So this is going to be our pretzel cost. So when we take a look here, that's going to be this bottom equation, $1.50 for 6 bottles of sparkling water, $2.99 for 2 packages of pretzels. That's our budget. In this one, I would say this one looks like it could work as well, except for this one is just the generic equation or the general equation where we know specifically how many sparkling waters and pretzels we need. If we didn't know how many people were coming, we would want to use part C. So if we didn't know the number of people, we'd use C, but we do know, so we can plan very specifically what we're going to do. 8, the speed of an object can be found by taking the distance it travels and dividing by the time. An object travels at 100 feet in 2.5 seconds. Let speed s be measured in feet per second. So write an equation to represent this relationship. So remember, we want the distance divided by the time. That's going to give us the speed. So s equals, in this case, the distance is 100 feet divided by 2.5 seconds. So you could leave it like that, or you could divide it down and get that 100 divided by 2.5 is 40, and then we would say feet per second. Number 9, a donut shop made 12 dozen donuts to give to a school's math club. Which expression represents how many donuts each student would get if the donuts were equally distributed and there were X students in the math club? So in this case, it wouldn't make sense to take the number of students divided by 12 because we're not dividing up the number of students, we're dividing up the number of donuts. So we want to see dividing by X. And we see that in B where we're dividing by X. None of the others actually divide by anything. So B would have to be the case. And what's happening here is 12 times 12 is the 12 dozen. And then each dozen has 12 donuts. So there's actually 144 donuts in 12 dozen that we're dividing by X. So they're taking and multiplying the number of dozen there. So 144 total donuts divided by the number of students.